Hello! Today I want to show you in the next video lesson, in next video tutorial, settings in Simplify3D about extruder. What the hell these numbers means? Okay, we will go number by number. This just tool 0. Probably you have one nozzle 3D printer, just select tool 0, tool O. Nozzle diameter. Of course, this is diameter of hole in your nozzle. Actually, if you have nozzle 0.35 and you will use settings 0.4, this is no any tragical mistake. But of course, why not use right number? This is just your diameter, nozzle diameter size, diameter of hole in your nozzle. Extrusion multiplier and extrusion width. These two numbers are connected, and I hope I will be successful in explanation what these two numbers mean and how are they connected. I personally named this first number like dummy extrusion and this second number like a smart extrusion. Dummy extrusion, smart extrusion. Dummy extrusion. This is just amount of filament which will go through your nozzle. No more, no less. 1, it means 100%. If you want, without any other effect, just 20% of filament more in your print, you will just change this number on 1.2. Yes. If you want to make lighter or less extrusion, you will just set 0.98, for example. You can see in different files that some high quality prints are sliced with number smaller than 1, and some prints which could be strength and solid are sliced with number bigger than 1. 0.03, it means extrusion plus 3% of material more. But standard settings is just 1, it means 100%. This is really easy, no rocket science. This second number, this smart extrusion, this is a little bit a rocket science. This number means thickness of your extrusion which will be used for drawing of graphic. And if, for example, your graphic is too tiny for this thickness, this graphic will be ignored. Yes. Imagine that like a thickness of your pencil, of tip of your pencil. With really thin pencil you can draw really small details. With thick pencil you can draw only large lines or thick lines. I will show you it on some example. I will use this number 0.4 millimeters. I will hide this this object, and I will import from my computer some object logo of my wife, but where is it? Here. Here. This is just some logo. I will make it smaller. And look, I will try slice this object with 0.4 extrusion width with pencil, with tip wideness, with width of tip 0.4. And look at that. I will show layers and only last layers. Here. This is a rest of letters on top of logo. Why these letters are not complete? Because are too thin for this extrusion width. If I will use smaller extrusion width, I will make a thin tip of my pencil for drawing of these details. Look at that. Now are all letters here. But of course it's not so easy, because I won't use extrusion width 0.2 on nozzle with hole 0.4. This of course could be really hard to reel through 3D printing. If I will print this logo with these settings, probably I will have problem with small material amount, small filament amount. But I can help with this dummy extrusion multiplier, with this dummy extrusion. I can set number, for example, 1.2, and it means it will simulate this extrusion width. It means nozzle with this diameter will just put smaller amount of filament, but I can use this extrusion ratio or extrusion width. I can use this number for drawing small details, and with this dummy extrusion I can add more material to this extrusion. It's not so complicated how it looks, just try that. These numbers are really important, for example, for 3D printed RC airplanes by Czech company, 3D Lab Print. Maybe you know that. Just flyable RC airplanes, and I can show you which problem we can have if we will use wrong settings. Okay, this is part of wing. This wing is with some outer surface and with inner reinforcement. This inner reinforcement is printing independently, I don't know if this word is right, on outer surface, because we need print of outer surface without a stopping, and after that we want print inner reinforcement which will be connected with outer surface. But this movement of nozzle must be continuously. Look at that. We can see that outer surface is one line and inner reinforcement go, and inner reinforcement are something like independent objects, and this will works only if we will use right extrusion width. All these objects are prepared for extrusion width 0.42. If we will use smaller extrusion width, for example 0.2, we will have a problem because extrusion width will be too small and inner reinforcement will be not connected with outer surface in real print. And if we will use a thicker extrusion, for example 0.6, we will have huge problems with print. Look at that. Because with 0.6 extrusion width, he will not print outer surface separately and inner extrusion, inner reinforcement separately. He will just go with nozzle and he says, okay, this is too near to this part for 0.6 extrusion. Okay, I will join them together. Here too, I will join them together. This is of course wrong. Yes. And all these mistakes are only through wrong extrusion width. So I need to use right extrusion width, right smart extrusion for right building of objects, and if I want more or less material, I can control it through dummy extrusion by extrusion multiplier. Okay, I hope you understand me. If not, sorry. Next, use control, retraction. What is retraction? I hope you know what is retraction. Retraction is just protection against ooze. Just some filament between printed parts. This is just amount of retraction. 0.5 or number around this number. This is normal value for printers with long extruder, with long extrusion, like Prusa. Prusa is short, like Ender 3, CR10, some Delta printers will use this longer extrusion. Printers with short extrusion, with direct feed extruders, like Prusa, like Felix printers, will use much smaller numbers, about 1, under 1, no problem. But extrusion or retraction is not only about this number. I can hide a seam in print. You know that. I will delete this part and I will show this small circle. You know the seam. Almost on all printed parts you can see a small seam in a place of retractions. Why all of it? Why I will not see retractions here? Because retractions are off. So okay, now our retractions on, and in place of retractions I will see a seam. Seam could be good thing and a seam could be a wrong thing. What is good on seam? Par width seam will be probably strength enough. Seam, it means that perimeters are connected one together. It means start of perimeter is connected to end of perimeter. Yes, but of course seam could be really ugly on prints where you want nice surface. Then you can control seam with these numbers. Coast at end, we will start with this number. Coast at end, it means this number before end of perimeter will stop next material, next filament movement to your nozzle. Nozzle will go right way, but this distance before end of perimeter will stop next material movement to nozzle. I will show you it. It is easy to show. You can see it here. Yes. It means I will show you it on this animation. It means tool head will right path, but in this point printer will stop movement of filament to nozzle. Yes, and in this part of print filament will goes from nozzle only from rest of filament in a nozzle, because of course in a nozzle is still some filament under pressure, and if here printer will stop movement of filament, this short part will be printed just only from rest of filament in the nozzle. It will make a seam almost invisible, but it could be make a print final part less strength. So be careful about that. And this is good not only for hiding a seam, this is good for a smaller oozing between parts, because if we'll start movement of filament printer in this part between on end of perimeter, probably ooze will be much smaller during movement to the next part. Next is wipe nozzle. What it means? This is next tool for control of ooze or control of seam. Again, I will show you it. Look at that. Tool head or nozzle will finish a movement, finish a perimeter, and small amount, a few millimeters, just distance which you will set, it will move under start of perimeter. It means seam will be more strength, and if is in nozzle some amount of filament, it will it will be wiped. It will be wiped on this wipe movement under already printed perimeter. Next is extra restart distance. Extra restart distance must can be with plus number or minus number. If will retraction start, retraction distance will be, for example, 4.5 millimeters. 4.5 millimeters will go back to the nozzle, and before start of new perimeter, this amount of filament will go again back from the nozzle, and it could be not enough. Maybe during movement some filament leaking from the nozzle, it make it ooze. Yes, it is possible, and you want to add some special material on start of each perimeter, actually on the end of each retraction, and this is this number. If I will use number, for example, 0.1, it means retraction will start with this number 0.5 will go to the nozzle, and on end of retraction 0.5 will go from the nozzle plus this number, and this is extra material to start of new perimeter, and this number could be -2. Why? For example, for more invisible seam. All these numbers could be very fine for nice printer, but it could make big problems in your print if you use them without any just if you will not use this numbers smart, it will probably make ugly prints. So be careful about these numbers and try it. Retraction vertical lift, this is just number. During each retraction will nose go up on 0.2 millimeters, or just number which you will set here. Why it is okay? If you have tall prints, you can meet the problems. Then nozzle will hit during movement. Printer or nozzle will hit the print on top side of print, and it will break your print from the hotbed. But with this number, nozzle during movement, actually during retraction, but the retraction is in almost all cases is retraction during movement. So during retraction, it means during movement, nozzle will go up on this distance. Okay, which numbers are usable? For example, for printer like under 3, you can use this this number. Okay, maybe this number. You can try it, it will probably work. If you use a printer with short extruder, with direct feed, something like that. But sometime is best simple setting without any specialties. Yes. Try it and you will see result. If you will know relations between these numbers, you will know about 70% of all 3D printing chemistry. Yes. So thank you for watching. sorry for my English, and I hope for someone it could be useful. Have a nice day.